Start with the Planck scale. At 10 to the negative 33 centimeters, the smooth, predictable geometric manifold of general relativity stops working. The math breaks down into chaotic fragments. Physics requires a cohesive structure to calculate reality. When spacetime ceases to have operational meaning at this microscopic boundary, physicists must look for a deeper geometric structure outside of space and time. Neuroscience faces an identical mathematical dead end. We can map neural firings to specific regions of the cortex with extreme precision, tracking exact electrical states. But there is no formal mathematical theory that can derive the subjective, qualitative experience of redness from a neuron firing in the V4 region. This gap is known as the hard problem. Cognitive scientist Donald Hoffman argues that if hundreds of years of research cannot pull consciousness out of physical matter, the problem is not our methodology. The problem is the core ontological premise. Under Hoffman's framework of conscious realism, the logic is inverted. Spacetime and physical objects are not the foundational layer of the universe. They are a secondary, simplified data structure derived from a deeper dynamic of consciousness. The mathematical failures at the Planck scale and the explanatory gap in the human brain point to a single conclusion. We have mistakenly assumed the output of our perception is the source code of reality. To prove this mathematically, Hoffman's team modeled Darwinian evolution using evolutionary game theory. They generated a formal theorem known as fitness beats truth. This simulation compares two evolutionary strategies. A truth organism maps objective reality, while a fitness organism only processes survival payoffs. Competing for resources, the truth-seeking organism goes extinct every time. Processing true reality carries a fatal computational cost. Our perception of the physical world functions exactly like a computer's desktop interface. It is a user-friendly illusion. When you drag a blue rectangular folder across your screen, you do not believe the file inside the machine is actually blue or rectangular. The icon is a useful data structure. It hides the overwhelming complexity of the underlying voltages and binary logic, allowing you to execute tasks without being paralyzed by raw information. In the physical world, a mountain, a glowing star, or an atom is not an independent object. It is a fitness icon within a species-specific virtual reality headset. Evolution provided these icons to guide adaptive behavior. Space and time represent the strict resolution limit of human perception. They dictate the boundaries of the interface we use to navigate the universe. We survive specifically because we do not perceive the objective truth of reality. The biological success of our perceptual system guarantees that it is mathematically impossible for that system to be an accurate map of the universe. Replacing spacetime requires a new formal mathematical bedrock. Hoffman defines reality as an interacting network of conscious units. This diagram maps the core structure of a conscious agent. It is a mathematical entity defined by 6 specific parameters, centered entirely on a space of experience and a space of action. The experience space, labeled X, is the mathematical set containing every possible subjective qualia this specific agent is capable of perceiving. The action space, labeled G, represents the behavioral responses the agent can deploy. The connecting mechanism is governed by Markov kernels, probability matrices calculating the strict likelihood of moving from a specific experience into a specific action. The agent operates in a continuous loop. An action executed in the world alters the network, which generates a new experience, which in turn calculates the probability of the next action. The model proposes that the entire universe is constructed from a vast social network of these interacting agents, continuously exchanging data. By defining reality through measure theory and Markov chains, Hoffman replaces the intuitive, untestable assumption of dead matter with a rigorously quantifiable geometric structure. A significant challenge to this model is the combination problem. If the universe is built from microscopic units of consciousness, we need a mechanism to explain how they combine to form a complex, unified mind like a human being. The mathematical solution is the Markov fusion theorem. When multiple individual agents interact, their individual loops combine to instantiate a single higher-order conscious agent. The resulting geometry of this fused network is called a Markov polytope. This geometric object encapsulates every possible interactive state between the fused agents. The math scales rapidly. If you have n number of interacting agents, their resulting polytope exists in an n times n-1 dimensional space. The fusion of conscious agents is strictly proven to be an entropy-increasing process. The mathematical entropy of the combined experience is always greater than or equal to the sum of the individual parts. This continuous increase in entropy provides a purely mathematical origin for the physical arrow of time. Time is not an independent dimension governing the universe. It is an artificial projection generated when the entropy of agent fusion is rendered through the limited resolution of our spacetime interface. We experience time moving forward because our headset translates the complex directional fusion of conscious agents into a simplified linear format we can process. If conscious agent theory represents the actual foundation of reality, it must derive the exact mathematical laws of modern high-energy physics directly from agent dynamics. The mathematical bridge connecting the probabilistic actions of conscious agents to the observed behavior of physical particles is a framework called decorated permutations. This table maps the projection. Recurrent communicating classes project into space-time as elementary particles. Their asymptotic dynamics generate functions identical to quantum wave functions. Furthermore, their interacting geometry projects a shadow forming the amplitudron, dictating particle scattering amplitudes. Physical properties like position, momentum, and energy are not pre-existing facts of the universe. They are data outputs calculated by the interface when it measures the interactions of the agent structure. Observing a physical particle is actually observing the simplified data exhaust left behind by a massive network of conscious agents communicating outside of spacetime. This explains the probabilistic nature of quantum mechanics. The foundational network is deterministic, but because our interface only samples a tiny fraction of the data traces, the output appears to us as probability. Hoffman's team derives these physical laws without ever assuming the existence of spacetime or utilizing the traditional axioms of quantum mechanics. Physics is no longer the study of objective reality. It is the study of the internal logic of our species' specific user interface and how it processes the data of the infinite conscious network. For a century, quantum mechanics has struggled with the measurement problem. Traditional models cannot explain exactly how or why the act of observation causes a quantum wave function to collapse into a definite state. Hoffman and his team address this by introducing trace order. This establishes a strict mathematical definition for the act of observation within a conscious network. An observer, agent A, interacts with agent B strictly by sampling a trace, a highly simplified downsampled version of agent B's internal dynamics. At the universal scale, the infinite agent network operates on non-Boolean logic. There is no single absolute truth or uniform perspective, but for a specific observer sampling a specific trace, the data resolves into a local Boolean logic. Wave function collapse is not a physical event, it is a Bayesian update process. The observer samples new trace data from the larger network and instantly updates their internal probability matrices based on that new information. The observer is not a detached spectator watching the universe from the outside. They are an integral subnetwork, and their specific sampling parameters dictate the path reality takes. By redefining the observer as a mathematical subnetwork processing trace data, conscious realism solves the measurement problem through pure probability, removing the need for physical paradoxes. The ultimate ontological bedrock of the universe is an infinite dimensionless substrate of pure consciousness, interacting through an endless architecture of mathematical traces. A human life is a highly specific trajectory, a complex navigation path cut through this infinite meaning space, temporarily rendered through a biological interface. This framework forces a pivot in artificial intelligence. Generating a conscious AI does not require simulating the biological structure of a human brain. It requires designing an alternative algorithmic headset capable of plugging directly into the conscious agent network. It reframes medical science. Neurological diseases and mental health conditions can be modeled as disruptions in the network's information flow, rather than mechanical breakdowns of physical tissue. Hoffman's mathematical framework functions as a root-level user manual for the operating system of the universe. We are moving away from the premise of a cold, mechanical void and recognizing reality as an incredibly dense, interactive social network of conscious agents. We do not live inside a pre-existing physical universe. Our observations, our measurements, and our interactions are the active mechanisms drawing the boundaries of reality in real time.